Okay, so everybody, for the most part, probably had to look up if they don't remember, because we did talk about it a little bit. Composite functions, with their notation that they use a different notation than we use. We put a little 0 or an O or whatever you want to call it in between the f of g or the g of f, and you would have called it fog or golf. They don't put a space in between there. They just say gf of x. That means g of f of x. So you should be able to do that one hopefully very easily. In case you don't know their notation, when it says f colon x arrow 3x minus 1, that basically just means f of x equals 3x minus 1. That's a notational thing that you may have had to look up, but that's all it means. That's just telling you what the function is. It's a different way of writing it than we're used to, but it's not anything that is difficult. You just have to know how they write things. And you should have done this already when we did it in our AICE math other book. It had the same thing. So it was f of x and g of x. 3x minus 1 and 5x minus x squared. And they want you to write g f of x equals, and then they want to, in their little completed the square form, which is fine, but they want to do g of f of x. So what does g of f of x mean to do? I can barely hear you. Almost didn't know you were talking, Nolan.
I'm sorry, I still have workers at my house and it's really loud in here, so I don't want to be like I have to wear earbuds. So, is that where you plug the f of x function into the x of the g of x?
Correct. Remember, with composite functions, you plug the inside one into the outside one. So I'm going to plug f of x into g of x. So 5 minus 3. I highly, highly, highly suggest you always do this in parentheses, whether it's easy, difficult, or not. Always plug it in parentheses so you know what to do next. One of the main reasons is this over here is going to mess you up. Since we need to write it in their form, we will have to distribute this out. So you get 15x minus 5 minus 9x squared. And again, being very careful with this distribution and the negative out in front. I leave it out in front with the parentheses there before distributing the negative to make it a lot easier on everything. So you get 15x minus 5. Combine all of our like terms and rewrite things slightly. So we're going to get negative 9x squared plus 21x minus 6. So we get that. And now we just need to do our completing the square like we did last week and get it into their form that they want, which is a minus b x minus c squared. Okay. So the first thing I'm going to realize is that I'm going to complete the square on this part, and then this part will get moved out front. So when I go to complete the square like we talked about last week, you need to factor out here. This one's going to be a pain in the butt since I can't factor out a 9. Let's see what's going to be the easiest way to do this one for you guys. So I would just factor out the 9. I don't think we have much of a choice but to have fractions. So it is what it is. So we will have to factor out the negative 9. So you get x squared minus 21 over 9 minus 6. Remember, you don't have to factor the 9 out of the end term. You only need to do it out of these two. I forgot my x. And then we can complete our square, so I will leave the blank plus blank minus 6. And then on the outside of the parentheses, we have to be careful. What am I going to do with the number? Am I going to add or subtract the number outside the parentheses in this case?
Subtract.
Why do you say subtract, Deborah?
Because the one inside the parentheses is subtracted, and this one would have to be addition, but it's because of the negative outside of the 9.
I think you've went too far on your analyzation there. So what is the one
It
on the
made sense
inside?
in my head, and
What
I
is?
kept talking. The one on the inside is positive.
But hold on, what are we doing with it?
You're multiplying it by a negative.
So I am actually.
The opposite of what it's supposed to be, theoretically.
So I am
Negative?
subtracting. So what are I gonna
Yes.
do on the outside?
Add,
You have to add.
which is really subtraction.
No, it's actually addition. Because it's on the outside of the parentheses. You went too far in your double negative thing. So the one on the inside, we will be subtracting really because I have the -9 out front. So on the outside, I have to do the opposite of that, which is adding. So you got to be careful with that part. And then just complete the square. You'll have some fractions, but remember you have a graphing, or scientific, you'll have a graphing, but scientific calculator. So cut 21/9 in half, square it. This is, it'd probably be easier, I guess, if we simplify 21/9. Let's see if it does. I don't think so. It becomes 7/3, but not the, oops, 7. So cut it in half and square it, so that's 7/6, so 49 over 36. In case you don't remember, if I take 7/3, cut it in half, I get 7/6. So square it, put it in both blanks, and then just finish your complete square. So you get, and they want it in a specific order, so let's do that fractional math. So I don't, was it 256? I think, or is it 216? I can't remember. Where's my calculator?
Then it's 216.
Is it two? I think I feel like it was 216, but I didn't want to do 249, 216 minus 49 either in my head. I just woke up and I don't feel like doing that. I'm gonna need my calculator at some point anyway. So 216 minus 49. We get 167. Pull you back up. So we get, was it negative 167? How'd they get a positive number? A positive number out in front for their answer. How did I mess that up? Oh, I made a mistake. Somebody found my mistake. That's how.
Isn't it up at the top when you factor?
No, I never factored. I distributed.
Or, I mean, that's what I meant with the 3x minus 1 when you distributed that.
No, that's done correctly.
Okay.
It's towards the bottom. I'll give you a hint. It's a really easy mistake to make.
Is it minus?
Is what? Okay. Okay, I'll give you more of a directed hint. It has when I was doing completing the square. Okay, I'll give you more of a hint. It has to do with the 49 over 36.
49 over not.
No, 49 over 36 is correct because you have to cut it in half, so you get 7/6.
Oh, yeah.
But it's something to do with the 49 over 36. Okay, more of a hint. It has to do with the 49 over 36 outside the parentheses.
Did the multiply it by 9?
There you go. Don't forget to multiply that by the number out front, which I forgot to do. Very easy mistake. This is why we practice this stuff. So this is times 9. So again, use your calculator to do all of these calculations since there's no reason to do it by hand. So you get -6 plus 49 36. Fraction. And we get 25 fourths if you do that. So do this part in your calculator, you get a positive 25 fourths, which is the correct answer. Minus 9x minus 76 squared. Bless you. So tedious problem, nothing more difficult than anybody here can handle. Keeping that in mind. Any questions on what I did? Okay, moving on to number 2, which is really quick and easy. So this is where they start looking at some of their transformations, which hopefully you remember from Algebra 2, Pre-Calc, Trig, etc. Easy one first, the negative out in front. So y equals negative f. What does that negative do? Anybody remember?
Flip across the x-axis.
Barely hear you still, Nolan. I understand you're got workers and everything, buddy, but
Reflect over the x-axis.
so that is a reflection. I always, when I talk about transformations, I always try to help with the understanding. You have one of two options: it's an x thing or a y thing. So the negative out in front is not inside with my x's, so it's a y thing. I'm flipping the y values. If you flip y values, that means you got to flip them across the x-axis. That's how I remember these things. Then the same deal goes with the inside. You have 1/2 times x. That's an x thing, so that's got to be a left or right thing. So what does multiplying by a number do? Does anybody remember that?
It makes it like 3 times bigger or whatever.
I'm really curious where you got 3, but okay.
Well, I don't know. It's just a thought. It makes it like that many times bigger.
Okay. Or,
A stretch or compression.
okay, yes. So it could have been bigger or smaller. You got to be careful because it can make it smaller. So usually numbers bigger than 1. And I'm only talking about the value, not the negative or positive part. Numbers bigger than 1 make it bigger, obviously. Numbers smaller than 1 usually make it smaller. However, x's are backwards. Do not forget that. X's are always backwards. So the 1/2 on the inside is actually not a multiply, not cutting it in half. It's the flip of that. It's making it bigger by 2. So very easily, this is a flip across the y-axis, and then it's a stretch horizontally by a factor of 2. So in this case, you're going to flip it down to the negative 2 on the y-axis, but instead of being at 3, it's actually going to be a value of 6. And I mean, I don't really need to draw that because if you look at the answer, it's there for you. So you just have to remember what these transformations do in order to graph anything like that, and it's very possible you could have stuff like that, and also domain and range and stuff. But always remember, make notes to yourself if you have to, that transformations with x are backwards. So in this case, it'll be a stretch of a factor of 2, so it'll go out twice as far. So instead of being at 3, it'll be at 6. And then B, same thing. It's there. I mean, the answers are there for you, so it shouldn't be too bad. You should have checked yourself. But we have to remember what these transformations do. So a couple of different things you can do, so you can see how they got their answer. And the way that I would actually prefer you to do it if you're doing something like this is if you have f of 3 minus x, you should rewrite this as f of negative x plus 3. You always want your x to be positive, and if there's a negative, obviously you can sit out in front of it, but you need to factor that negative out of everything. It'll make your life a lot easier. And then as you're doing your transformations, you always start with your adding or subtracting and then do your multiplication. So do the add or subtract first. So this is a shift left 3, and then a reflection across the y-axis. That would be the easier way and the preferred way of doing it.
Wouldn't it be x minus 3?
Yeah. So that's a shift right of 3. Remember, your x's are always backwards, so minus 3 looks left, it's actually right. Thank you, Deborah. So that's just a basic reflections and translations and stuff like that. You just need to know which ones they are. So adding and subtracting is a translation, and multiplying is a stretch. Negatives are reflections. So. All right. Question 3. I'm not going to do part A on number 3. You guys can find your x and y intercepts, I hope. And I mean, it's just straight up factoring because it's really easy to factor. And find your y intercept. So I'm not going to do A. Unless anybody has a question on A that has done A. Okay. Alright, so part B though does take a little bit of work. Let's see what's going to be the easiest way for you guys to do this one. Alright, so for this one, the easiest way, which you may not have thought about possibly, would probably be to go ahead and put this parabola into vertex form, and then go from there. So, we have what? X squared plus 6x plus 8. So you should have already found your x-intercepts and stuff like that. You should know your parabolas. Vertex is right in the middle of that. You could find your minimum point by your calculus, however you want to do it. But you should know that it's, what, x, and then it was, what, 4 and 2, so minus 3 squared plus 3, oops. Plus, let's see what that 9, nope, minus 1. So a couple ways you can get it into this vertex form. One, you can complete the square. That's perfectly fine. 2, you could find the vertex from calculus and know how to put it into vertex form. Remember in case you don't remember, x minus h squared. So your vertex form from pre-calc for a parabola is x minus h squared plus k. So you can do it pretty much any way you want. Your h value in our case was -3, so that's why it becomes a +3. Remember, your vertex is always directly in between your two x-intercepts if you have x-intercepts. You could also find these values through calculus, plugging in 3, etc., -3, and finding your y. But this is the easiest way to do it. They've then told us that we are shifting this parabola right 2 and a stretch of 3. So we are doing 3 times, I guess this might have been easier, x minus 2. I guess it probably would have been easier just to do this. I didn't even think about that. So you just plug in x minus 2 and then factor. So there's 2 ways to do it. So I would say then you get, what's this, 3 x plus 1 minus 1. You can do it that way, so then you do your stretch, or you can just plug in. I didn't even realize that. That's 3 times x minus 2 squared plus 6x minus 2 plus 8. So you can do it one of 2 ways. You should get the same answer either way. Oop, I forgot my square. But don't do this way. It'll be harder. This way is actually easier. I didn't even think about that until I started doing the problem. So they just want you to do the transformation, which would be 3 times f of x minus 2 since you're shifting it to the right 2, and then get your answer. So the bottom way will be much easier, so don't even look at the top way or think about trying to do the top way. There's a lot of compensations and things that need to be changed for you. So multiply it the bottom way and get the answer they want. That's pretty easy. Okay. Alright. I'm not going to finish that up because you can do that. Alright, part 4. Ooh, I'm going to assume everybody knows what that notation means in number 4.
Inverse.
I think my headset just went sleep mode on accident. Oops. Everybody should know the notation on number 4. Yes.
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 Okay, good, because we have done this before with calculus. So how do we find the inverse? We've also talked about this briefly. How do we find the inverse?
You have to
Both
switch
the
your
X's
X
on
or
the
Y
board.
and
Don't you
solve
just
on the Y.
substitute the variables?
No, there is no substitution of variables. Deborah was correct. Switch your
I mean
x
switch.
and y and solve. So remember, you change your f of x back to a y, g of x, whatever function they're giving you. So you get x equals y squared minus 2. So y is equal to plus or minus the square root of x plus 2. Okay, but there's an issue with what I have on the board. What's the issue with what I have on the board?
We'll determine if it's plus.
Yes, we have to determine if it's plus or if it's minus. That is very important. You cannot have both. If you have both, that is not a function. So do I need the positive one or do I need the negative one?
The positive one.
How do you know it's the positive one?
Because the domain is greater than 0.
That is close. But you haven't explained to me why the domain being greater than 0 means that I have to have a positive one.
Yeah, I can't tell you that.
The domain for the f of x was greater than 0, so now its inverse has the range for the inverse of fx.
That is correct, Mr. Michael. Good job. Is it greater than or equal to or just greater? Okay, so greater than, yeah, or equal to. So for your original function, your domain is greater than or equal to 0, which means your range in this case is y is greater than or equal to 2. For the inverse, your domains and your ranges switch. This is a very important fact when answering these questions because most people here will get this domain part wrong for a composite function if you're not paying attention to your original domain of your function. So now our new domain is x is greater than or equal to 2. However, does the range stay the same? I'm sorry, that's negative 2. And then the range sometimes will not. Sometimes these mess up with composite functions since this is just a straight inverse. It will not mess up any. But y has to be greater than or equal to 0, so we get to get rid of both the positive and the negative.
Why is it negative 2?
Because if you plug 0 into the original function, it only goes up from there, so 0 goes, and then -2 and goes up. So this function's lowest value is at -2. You should know it being a parabola for 1, it starts at -2 and does that, as you'll see in a second on the board. We only want the right-hand side, so we actually get to erase this left-hand side because that's not part of our domain. So all I have is that right-hand side function because my domain is restricted in this problem, and that is the smallest value for y. So we know our range is -2 up. Make sense, Diva? Deborah.
Yeah.
Okay. So specifically when they're giving you the hint here saying stating the domain of the f inverse, they want you to realize that they are just switch. So you have to find the range of the original and then switch it. And then they want you to sketch the graphs. We already have one of the graphs done. Remember, it's really easy. All you have to do is switch your x's and y's. So I'll try to do it in a different color. I don't know if you'll be able to see it or not. So this is 0, -2, so we go to -2, 0 over here. And then whatever value that would be, which is square root of 2. So that's going to be square root of 2. That's square root of 2. And then they'll meet somewhere in the middle. So it looks something like that. Remembering that they have a line of symmetry being y equals x. But the easiest way to graph them is to literally just get some x's and y's and then switch them. So since we have the -2, 0, we can switch that to being, 0, -2, we can switch that to being -2, 0. You have square root of 2, 0, you can switch that. All kinds of things you can just literally switch. So just find some coordinates on your original one. You might even want to do like a t-chart to help you. So for instance, you can do like x, y for f of x, and then do the same thing for the inverse. And then just do, so this one would be, what, 0. So this one's -2, 0. This was square root of 2, 0. So this one would be 0, square root of 2, etc., etc. So you just literally switch the x and y. That's by far the easiest way to graph that. And just get a couple points. And then sketch it. Any questions on that one? All right. Question 5. I am not going to do number 5 since we've already done a ridiculous, or A anyway, a ridiculous amount of completing this square. So to save time, I'm not going to do that. Okay, however, question B, I will answer, because you probably don't remember what 1-to-1 is, most of you, if you did not look it up anyway. So do we remember what 1-to-1 is?
A function is 1-to-1 if its inverse is also a function.
Okay, how do we tell if its inverse is a function, Kayla? I specifically want you to answer this.
Bruh, the vertical line test.
That's not what it's called.
I don't know.
What's it called?
Vertical drop test.
The vertical drop test. Okay, there's actually a slightly easier way of determining if it's a 1-to-1 function, though, than what she said. What she said is correct. If the function and its inverse are both functions, then it's 1-to-1, but there's a much easier way of knowing how to do that. Because do you really want to find the inverse of this function and solve for it? I'm going to hope the answer to that question is no.
Not really.
So what is then an easier way? Anybody know, by chance? Okay, so a shortcut in order to determine if it's a 1-to-1 function. As she said already, the function has to pass the vertical line test. That's easy. Duh. However, if the inverse were to pass the vertical line test, what does that mean that the original has to pass? Remember, you switch x and y. So a vertical test on the inverse is actually a horizontal test on the original function. So if you take a parabola, for instance, I'm going to assume everybody knows a parabola passes the vertical line test. I can move that.
Yeah.
However, a parabola fails what we call the horizontal line test. This is not a one-to-one function. The definition of one-to-one is for every one x, there's only one y, and for every one y, there's only one x. It goes both ways. So the parabola failing a horizontal line test means this is not a one-to-one function. So technically this function doesn't have an inverse. Now we can make domain restrictions and things like that in order for it to have one, like on the last problem. Notice how in the last problem we only dealt with half of the parabola. That's why they restricted the domain in such a way that they did, is so that we could have a inverse. Y equals x squared does not have an inverse function. It does have an inverse equation. You can switch x and y, so you get x equals y squared, and you get y is equal to plus or minus square root of x. You can graph that, and it's a sideways parabola. That does exist, but that's not a function anymore. That's an equation. This is where you did these in pre-calc with your hyperbolas and things like that, and all that kind of fun stuff. That's where you had equations, no longer functions. So this does exist. You can do this. However, it's just not a function, so we don't talk about it as often in lower level math especially. So you don't start talking about this kind of stuff until pre-calc and calc. So we want to say, okay, well, we don't like the fact that it doesn't have an inverse. We want to figure out where do these things have an inverse? For what values of the domain? If I restrict the domain, I can get an inverse, et cetera, et cetera. And that's exactly what they're asking us here. So really what they did in question 5 is they walked you through it. Part A is the first part of part B. So you should have been able to do part A. And you end up with this. So the whole reason for walking you through part A, at least in their minds, is so that you can find your parabola, or sorry, your vertex. Because a little hint here, for part B, your vertex is where you need to restrict your domain. So our graph would be, what, to the right 3, so 1, 2, 3, 1, 2, 3, 4. Let's see, where is it, 0? 2 would be at 5, and 1. So, what's my terrible parabola? God, that's awful. But anyway, that's a rough estimate of what your parabola looks like. You should be thinking this in your mind. No, they don't expect you to graph it, but this is what I think about, and I draw sketches to myself when I'm doing these types of problems to help me understand, especially since I'm looking at the vertical line test and the horizontal line test. Okay, and we need to restrict the domain. Is it above or below? Where x is greater than blank. So in order for this to pass the horizontal line test, I have to have x is greater than or equal to what?
Three.
Why 3?
That is where the vertex is located on X.
Yay, Michael paid attention to my hint I just gave you. For a parabola, it's always at your vertex. So x has to be greater than or equal to 3. So if we do that, we would erase the left-hand part of the graph, and you would get now a one-to-one function. So it could be bigger than 3. I could restrict my domain at 5 or 6 or 7. However, they asked us for the least integer, or smallest, is what they said. So smallest possible value of m is going to happen at a vertex. Any number bigger than the vertex, or if it was x is less than, any number smaller than the vertex would also work, because I would just keep erasing more of the graph if I was doing different numbers than 3. And notice this is worth 1 point. So they're really expecting you to realize that it's the vertex is the point and just state the value m is equal to 3. But this is the thought that goes into it, just so everybody's aware. All right, and then for part C, which I will do, they're saying if in the case where m is 5, so 5, which happens to actually be this part of the graph. Let me redraw this to make it a little better. Actually, it wouldn't curve like that. There we go. It would curve something along those lines. So again, drawing the quick sketch of the graph may be helpful, may not be helpful, et cetera, et cetera. But how long ago did I cut out?
Like at the start of the question.
Are you serious?
Yes.
Like start of which part of the question?
Like you just finished drawing the graph, and then I don't know what else happened after that.
Oh, boo. I wonder why my headset's cutting out. Okay. Anyway, so to re-explain. So I see Michael answered the vertex part. So we, at the beginning of this part, part C, not part, so we did part B. Michael answered that. Okay, so they are telling us in part C that m is 5. So they are restricting our domain so we can erase the part of the graph that is before x equals 5. So again, the graph is just there to kind of help you. It's not there for any actual points or anything, so they don't ask you to sketch it. So it's just there to help me visualize and understand what's going on. So what I would do again is kind of just draw that sketch like I said, and it gives you that idea. Since we are looking for the domain and range, I think, or just domain, that'll be pretty helpful for us for the inverse because we can now look at the graph and pick our domain and range pretty easily. But they want us to find an inverse function. When finding an inverse function, you do not want to use the original one. You want to use the factored one that you found in part A. You don't want multiple y values. That's a definite thing. So on the first one, if you look at the original equation where it's negative x squared plus 6x minus 5, you do not want to switch your x's and y's at that point. You want to only have one x and one y when you go to switch them. It'll make your inverse a lot easier. So you get x equals y minus 3. And then just solve for y, which I'm going to hope everybody here can do the algebra. So you subtract 4 first, divide by -1. I'll do it in steps for you. So then divide by -1 or multiply by -1, however you want to view it. So you get negative x plus 4 is equal to y minus 3 squared, square root. And then I'm going to add 3 because I don't feel like writing one more line. And you have your inverse. The question is, do you need the plus or minus in front of that parabola or in front of that square root? Is always a good question since we did take the square root. So which one do I need out there? Do I need the plus or the minus? Is the question. So we do have to check a couple of things and go back up here and look at our original domain and range. So our original domain was x is greater than or equal to 5. Our original range is y is less than or equal to 0. So my new domain and range has to be switched. So my new range needs to be positive 5. So it has to be greater than 5. So I do need the positive version of my square root out there. So we do have to check those kinds of things. If it would have been negative or smaller than something, then I might have needed the negative version. So we do have to be very careful. All right. Making sense for everybody?
Yes, sir.
Yes.
All right. And then just switch your domain and range, and you're good to go. So your range is, or domain is, well, x is less than or equal to 0. Alright. Holy Jesus, 6 has E. There's 2 1-point problems, so that should be quick. Alright, number 6. Plus k is defined. Okay, part A shouldn't be too bad. Don't let the k throw you off there. The k is not necessary, and it doesn't really matter. So, however, we will need this for future parts, so I'll go ahead and do it and write it out. I already forgot the problem. X squared plus 4x, I think. Minus 4x plus k. So f of x. Complete the square, pretty easy, so you get, this is a straightforward one. Oops. Actually, I'll write it out. 4x plus 4 minus 4 plus k. X minus 2 squared minus 4 plus k. And how exactly do they want it written out? Okay, yeah, so that should be what they're looking for. Yep. So that part shouldn't be hard, it's just we need that for the rest of it. So B, state the range of f in terms of k. So very easily here, what kind of function do we have? Okay, what kind of function do we have, people?
A parabola.
Oh my god, how'd you know that? Okay, so we should all know that's a parabola and recognize that very easily. How do we find the range of a parabola? Okay. Again, how do we find the range of a parabola? This is not a trick question, not super hard. You guys know how to do this.
Would you just find the vertex and then know whether it's facing up or facing down?
Uh-huh. So, and you don't have to find the whole vertex, you actually only need the y coordinate because we're doing range.
Yeah.
So what is the y coordinate of the vertex is the question. And your y coordinate is that right there. Remember, x minus h plus k. So whatever's outside the squared part, that is your y coordinate. So this will have a vertex at 2, negative 4 plus k. And which way does this parabola face? Again, which way does this parabola face?
Upwards.
So what do I know about the range? What about all the y values?
They're positive.
They're not all positive because we don't know
I
k.
don't know.
But what do we know?
They're above it.
They're all above it. So our range is that y is greater than or equal to negative 4 plus k. So this is why that's one point they literally expect you just to put that's it. I mean, really, there's no. And apparently they rearrange it to be k minus 4, but whatever. Okay. And then part C, again, 1 point since we've talked about this again. the value for p, where p is restricting our domain from the original question. What value of p, the smallest value, will give me a one-to-one function? So again, where do I need to break this graph in order to make it a one-to-one function?
Oh,
I gave you the hint earlier. You should have written this down.
At the vertex.
Thank you, Michael, again, for the second time. So you need to break it at the vertex. In this case, we're talking about the domain, so the x values. So I need to break it at what value?
2.
Yay, 2. So just break the vertex at 2, so p-value has to be equal to 2. All right. So those are 2 straightforward questions that literally you answer from the factored form. So part A, B, and C really all go together in one problem. All right, part D, however, apparently is 4 points. For the value of p found in part triple I, there is no part triple I. Haha, you made a mistake. Find an expression for f inverse and state the domain of f inverse, giving your answer in terms of k. Okay, so basically they want you to just find the inverse. So your function here, if x is greater than that, it's fine. Okay. So you get x squared minus 4x. Actually, we'll put it in this form. So you have x minus 2 squared. P was what? 2? So minus 2. So you get that function. They want you to find the inverse. So just like we just did. So you get x equals y minus 2 squared minus 2. X plus 2 equals y minus 2 squared. X plus 2 plus 2. And then again, the only question we have to ask ourselves when finding our inverse here, do I need this plus version? Do I need the minus version? What do I need? Oops. And I made a dumb mistake because I wasn't paying attention. So, what mistake did I make very easily? Because I'm not paying attention. I'll give you a hint. It's in the first line. Nobody sees what I made a mistake on in the first line? Anybody? Somebody, please?
Do you need K?
Yeah, I don't even have K in my thing that says in terms of K. So where did my K go? Let's see who's...
In the same spot? I don't know.
I got rid of K, because let's see who's paying attention. Nobody was paying attention to what I did. So I said K was 2. Why did I say K was 2? What value is 2 that we just found?
P.
P. I said P was 2, and then I replaced K with 2. And nobody's paying attention enough to catch that.
I was wondering why you had 2. Minus 2.
Because I said K was 2 for some reason, so that will change a couple of lines, but not much. So minus 4 plus K minus 4. So now I just need to move that over. So it's not much. So we get x plus 4 minus K equals y minus 2 squared. Take the square root. Was it plus 2 equals y? So now the only question is, do I need the positive version of the square root out front, or do I need the negative version of the square root out front? So we have to remember that from our original problem, the domain now in question is x is greater than or equal to 2. So what do I know about my inverse function? Okay, I'll repeat, since I just wrote on the board that the domain is x is greater than or equal to 2. What do I now know about my inverse function?
The range will be y is greater than or equal to 2.
So does that mean I need the positive version or the negative version out in front?
Be positive.
I need the positive version. If I had the negative version, it would be going smaller because it would be some negative number plus 2. So I have to have the positive version. Okay, and then what is my domain for the inverse? Because they do ask us for the domain. Somebody besides Michael, Miguel, or Thomas this time.
Huh?
I said, what is the domain? Somebody besides Michael, Thomas, or Miguel this time.
X is greater than or equal to -4.
Who was even talking?
Nolan, he's quiet. I upped his volume so I can kind of hear him.
I'm
And
trying. I'm sorry.
you're fine, buddy. You cut out at the end, though. You said x is greater than or equal to -4.
Plus K.
There you go. So all you gotta do is take the range, switch it to your domain. Not a super difficult question. Okay. Any questions on what I did there? All right. We will pick this up tomorrow. Again, a lot more people need to be participating and saying stuff and answering questions, not just sitting there, because now I don't know if you're sitting there or not at all, other than the fact that all of you are about to leave immediately because class is over.